so first of all, a little recap of substitution. And normally, in substitution, we would be looking for a function inside of another function as the main hint. So you look at some of the ones that we just finished up. Oh, here the tan x is inside of sine. That is your biggest hint for what you're going to let u equal. And then secondly, once you see a function inside of a function, you look, is the derivative or some form of its derivative close by? And sure enough, the derivative of tan is secant squared. What makes this last one a little bit different is there's no function inside of any other function. It's just sine x times cos x. That being said, we do have a derivative present. The derivative of sine is cos, and also the derivative of cos is sine. So if we let, and I'm going to do this one in 3 different ways, so this is the first way. If we let u equal sine 2x, then the derivative would be cos 2x times 2
Did Dempster leave or is he still in the building?
I think he's
done? Yeah. Okay.
So if we let u equal sine 2x, then the derivative would be cos 2x times 2 dx. And this would allow us to do the following substitution. We could substitute sine x for u, and 1/2 du for the cos 2x dx. And this does end up changing it to a much easier integral. So what would we do with this integral? Well, the 1/2 would stay. We add 1 to our exponent, and divide by our exponent, plus c. And you could substitute back. And if you would do the derivative of this function, you would get what we started with, which was sine 2x cos 2x. Perfect. Method 1. Now, since the derivative of cos is sine, well, it's negative sine, but it really doesn't matter the number in front, we could have also made u equal to the cos 2x. And our substitution would have been a little bit different. We're going to see what that looks like. If we let u equal the cos 2x, then the derivative would be negative sine 2x with a chain rule times 2 and so this time, when we rearrange, we would need to get the sine 2x by itself. So again, I'll write off to the side. The original question looked like this. This would be the same if I wrote it in a different order. And notice we're making u equal to this section, and we're making negative 1/2 du equal to that section. We're trying to substitute everything out of the equation to get it into, well, not everything, but we're trying to substitute the main functions out of the equation so that we get a simpler equation. So if we look at what we've color-coded now, our new integral is going to be u for the purple part and negative 1/2 du for the orange part. Similar to before, add 1 to the exponent, divide by the exponent plus c, and so now we get a completely different answer than we did in part 1, but it happens that the derivative is exactly the same, which is interesting. It does not mean that the two equations are the same, but the derivative happens to be the same. For method 3, we are going to use the following identity from grade 12. Your double angle for sine. That's sine 2 alpha is 2 sine alpha cos alpha. As far as using this formula working backwards, whenever you have sine times cos of something, you have part of the right-hand side of that formula. Notice we have sine alpha and cos alpha, we just don't have the 2. That being said, we could do this in one of two ways. Either you could take this formula and you could divide both sides by 2 and put a half on the other side and change it that way. Sometimes you will see people rewrite put the 2 in the equation and a half out in front. Do you see that those would cancel each other out? A half times 2 is 1. But when I do it this way, I would be able to replace the 2 sine 2x cos 2x using the formula. My alpha would be 2x. This will end up being sine 4x inside. And now I don't even need substitution because this is an ax plus b style of integral. How do we do the ax plus b style integral? We think, well, what would happen if I worked backwards from sine? The integral would be negative cos, but because I would have a chain rule, I would also have to divide by 4. And so we get a completely different answer than the first two answers, but all 3 of these would be correct, even though all 3 of them are different. That bothers me just a little bit. It should, I don't know, something about it should maybe bother you. It seems kind of weird that you get 3 different answers. You almost want to graph them all to look at them, and yet they're just weird. Okay, I feel like graphing them on something, checking it later. But this is where we're going to, that's why I left this one for today.